Okay, I am back again. Sorry, I had to cut the first one short because I was doing this on my lunch break. So we'll finish this up with the last part here. And what I was going to show was I was going to show what the signals looked like when I disconnected the sensitive edge switch on the right inside the exit door. So I'll show you the captures when I disconnected it. And here I've got both of my scope screens up. So if you look here for my 4425 scope signals, channel A is sensitive edge signal, B is sensitive edge switch across left, C is sensitive edge switch across right, and D is the voltage feed at the base plate connector. Okay, so let me zoom this one out so we can see it better. And this is after I disconnected the air switch. So I disconnected the air switch, and now my volt feed for D at the base plate connector, that's the voltage that's coming from the Vansco module in the back, it has gone back to normal. Okay, so let me go up to here to the gold channel D, and I've got 25 volts again. It's alive. And then on B is the sensitive edge switch across left. So now across that other switch I now have open circuit, okay, because the switch is open. So then I'm going to see a potential difference in voltage between the open portion of that switch. So I'll have 25 volts on one side, 0 on the other. So that's the reason why I'm seeing that now across that switch. And then the same thing when I disconnected from C, and that's the suspect switch, that's the sensitive edge switch on the right. I now have on it 25 volts. Sorry, I got too many cursors going on here. Let me get that out of the way. So now I've got 25 right here. Okay, so everything is back to normal now. Okay, so it's the switch that caused this whole problem. All right, so let me minimize this, and then I'll show you the other screen here. And this is me using my 4423 4-channel scope, and here on channel A is the rear door feed voltage. Also, I use this as a trigger. So channel A rear door feed voltage, channel D voltage feed at base plate. It's the same feed that I'm going off of, that I'm using as the trigger for the single shot trace for both scopes. And then once again, like I said, I've got it on rising edge for both. I'm at 2.953. You just type that voltage in so it can be exactly the same for both screens, and then make sure your sample interval is the same for each scope, and then it'll trigger at the same time. So anyway, on this screen here for the 4423, I basically see the voltage awake on this one, and then I've got current clamps on the sensitive edge circuits for C and D. And right now on C obviously is not going to have anything on it because I've got it disconnected from there. I got like 7 milliamps, something like that. And on this one, I think what happened with this clamp, I think my 0 line offset went away. Hadn't pushed the 0 offset button in a while, so there was no current on this one either. Okay, so anyway, that's just showing that the problem was that one switch, the sensitive edge switch on the right side. And then another thing that I noticed that was interesting, I did this again to just prove my point, that it was the faulty switch. So after I had it disconnected, I decided that I would then plug that one switch back in. Okay, so if you notice here, channel A is the sensitive edge signal, and then B is the sensitive edge switch across left, C is the edge switch signal across right, same thing, and then D is the voltage feed. Well, when I plug that that right side switch back in, I saw a spike in the sensitive edge signal going to the module, and that was on channel A. So when I did that, I had a spike a little bit of voltage going to the module, but then at the same time when that happened, my voltage supply from D dropped out. See, it dropped all the way down to nothing. And then the same thing happened for the voltage for my sensitive edge switch on the right. It went down too when that happened because I lost the voltage. Okay, so this is just another way to show that, you know, it was the sensitive edge switch causing this issue. And then on the other capture here, I've got the current on channel B for the rear door module, and when I plugged that in, my current also spiked. And it went over 60 amps easy. Notice how it got all flat here for the current. That means it basically went over the limit of the current clamp. So it's, you know, it's too much current. So that just proved that, you know, that was my problem, and I needed to replace the switches. And then as soon as I replaced the switches, the problem went away. The bus has not been back. This one was an interesting one. This took me a little bit to figure out, to be perfectly honest, but it was a good learning experience for me. I've never seen, you know, wave switches on these buses act up like that before. So if there's any transit bus people watching this, you know, if you've got an intermittent door problem where the doors cut out, you get the rear door light on the dash, you get the buzzer, you know, check those sensitive edge switches and make sure they're not shorting to ground. Okay, and this took a while to get it to act up. It seemed to me the best way to get it to act up in this scenario was, after I interviewed a couple drivers, was to get the bus hot. So I got the bus hot, and then it acted up. So anyway, like I said, this problem was very hard to find, and I'm just thankful when I found it. And this is a very good example of, you know, why you have to have a scope to work on these systems now, because the time frame when the problem happens is so small. It isn't funny. Here, let's do some cursors here for when this overcurrent happened and when it shut down the driver, and then I think everyone will have a better understanding of what I'm talking about. Alright, so B's the current. Let's get that up a bit. Let's do a cursor here on when it happened and when the driver shut down. Skip that. Alright. And then blue's the feed voltage for the rear door. Alright, so the current got up here, spiked, and then dropped off, and then the driver shut down. Okay, so if you look on the delta here between the two, 28.79 milliseconds. All right, so you tell me, how are you going to be able to know that you have a short to ground on this module without hooking up this scope? You are not going to know if it's a short to ground or not, okay? Especially if it's intermittent, okay? So this proves, you know, how valuable this tool is and how much you need a scope to work on these systems. So anyway, that's pretty much it. This is what I was wanting to show you guys and gals. But I hear a lot of talk about, you know, well, can you really use two 4-channel picos at the same time? And my answer is yes, you can. As long as, like I said before, you get your triggers set up properly on rising edge and make sure your sample interval is correct, and then line it up. A lot of the time I'll take the diamond and I'll put the diamond like in the very center of a graticule right here, just to get it lined up, and then I'll measure where, you know, on the screen where this is at, you know, and I'll line it up with one of these with a cursor too, and then I'll take my diamond and I'll put my diamond lined up in the center the best I can, just like that, and then I'll type in the voltage level right here, okay? And I've done it like that, and you know, it works pretty good. You know, it's like the only drawback is, of course, you know, if you take two 4-channel picos and you use a trigger, you know, for one channel, you actually lose a channel and you only got 7 channels, okay? But still, that's better than, you know, 4 channels. And, you know, to top it all off, with the automotive scopes, you get the protection built into them, so if something happens, you make a boo-boo, you know, it's protected and your scope isn't going to get damaged. And for a person like me, I can't always afford to drop another $2-3 grand on another scope, you know. I have to budget my money, so I decided to go the route of getting another automotive scope with more protections built in to protect me from making that mistake. So you can buy a, you know, a regular 8-channel pico, but the problem with the 8-channel pico, it doesn't have the automotive presets built in. Not that I really use a whole lot of the presets, but it doesn't have as much help or guidance as the automotive scopes, and the 8-channel pico does not have the protections, those fuses in there that will break inside and reset, you know, if something happens. So this is how I recommend you do it, everyone. I really think just get 2 scopes, get 2 4-channels, or heck, for that matter, if you just wanted to buy a 2-channel and then get a 4-channel, you could still link them together. It's the same thing. So anyway, if anyone has any questions on how I did my setup, on how you do it, just let me know, and I'll help you out. So anyway, I hope everyone has a good day, and take care. Thanks.